hello, welcome to the show. It's me, John Park. It's time for JP's product pick of the week. Thank you for stopping by, everybody. And thank you for your patience with streaming key issues. I have no idea why the streaming key needed to be regenerated. It seemed like it was a fresh one to begin with, but oh well. Thanks for popping in over on the chats. We've got our YouTube chat up. Hello to Dave Odessa, Autograph Abdel Hagen, Denny G73, Tyrone Mix, Tackle the World. Hello, hello, hello. Philip Urschler, Jeff McAvoy. Hello, heyo. And the other place, if you're wondering where is all the chatting happening and you're somewhere else where there's a lack of chat, well, check out our Discord. If you go to adafruit.it/discord, you can look for that live broadcast channel right there. And over in the live broadcast channel, hello to all these fine people. Hey, Liz. Hello, C. Grover. Thin Man. Howdy, Paul Cutler. Hey, David, WA90NY. Hello, hello. Jim Hendrickson. Hey, C. Grover. Did I mention those names? Yes. So let me get started here. Hold on. I'm going to pause a little distracting video monitor window over on the side, and we can get going. So we've got a brand new product pick. It's actually a suite of product picks, all related to each other. If you're paying attention, that might give it away right there. But what you can do is head to that QR code or that URL right there, and you will see this show embedded inside the product page. You can get a jump start. We have big discounts on today's product pick or picks. And before I say any more, what I'd like to do is have Lady Ada tell us all about it. So take it away, Lady Ada.
Okay, so this is a PiCowbell, which means it plugs in next to or on top of a Raspberry Pi Pico or PiCowbell and lets you connect a parallel, otherwise known as a DVP camera. These are digital video cameras that have a parallel interface. So you need to take advantage of the PIO interface on the Raspberry Pi Pico, but it works quite well. And it can quickly grab all the data from the camera and store it either to an SD card or keep it in memory. In the center there is the camera module, and there's like a standard pinout. It's like a 24-pin pinout. So there's different camera modules, different lenses. They all have the OV5640 camera sensor, which I find to be like the nicest one. Some people like the 2640. Lower resolution, I found not as high quality. I really like the 5640. And then I also have on the left, there's a little shutter button, pin 22. You can press it to take a photo or whatever. It's just like an extra button. A STEMMA QT port for adding sensors or whatever. In the middle is that camera sensor. You see the lens. Above it is a reset button, so you can reset the board. To the left, kind of in the middle there is all of the circuitry for supporting the camera. And on the right is a micro SD socket, so you can take images and then save them. So you can make a little mini camera. The only thing is there's no preview screen. If you want a preview screen, you'd wire it up like this. We'll show the pinouts. And then, you can have live stream video image from the camera come to the TFT, so it should show you a preview. And then you can also take photos and save them, like I said, to the micro SD card. So these come in a variety of different lenses, and each lens has like its pros and cons. So the first lens is like the biggest. It's the 160 degrees. So this is very, very wide angle. So if you see the photo, like the figurine in the center is very small, and you see like a very wide image, like a 160-degree image of the background, but it's kind of distorted. Like you see things are sort of at the edges, they're curved because it's got a distorting lens because it's such a, it's like a fisheye lens. We also have this is 120 degrees, so this is also a little bit wide, but it's a non-distorting. So if you look at the image, it is wide, but you see the lines are like mostly straight. It's a low distortion lens, but it doesn't have autofocus. We also have a 120 lens that does have some distortion. It's a little bit less expensive. You kind of, pay a little bit more. So you see this is it's got a little bit of a wide angle, like zoom in effect as well. There's also a 120-degree with autofocus. So that metal body around the lens is the autofocus circuitry. It uses a lot of power because there's a little motor coil inside that can move the lens up and down, and you have to load this firmware into the camera over I2C. It takes like a second or two, and then you can tell it to do autofocus, and it kind of works pretty well. And this is what that camera looks like. You know, it's a slightly different image. And then finally, we have a 72-degree, which is a non-fisheye. Like that's kind of when you think of one-to-one camera images, this is it. And it also has the autofocus. You can see like everything is exactly as you would imagine is if you see it with your eye. It's like non-distorted at all. You will use the narrow lens if you're just you know, wanting to take everyday photos of people and things. The wide angle lenses are for like if you're doing like some time lapses or you want to take a photo of like a backyard and you want to get the entire backyard, not just a narrow part of it. Because again, it's not motorized, like there's no pan, tilt, zoom, and so you can't move back and forth. So you just have like a really wide lens, and then even though it's distorted, you know, a lot of people when they make like a security camera or monitoring or a time lapse camera, they'll use a wide angle lens. That said, the code is the same for all of them. It's just like the lens is a little bit different. And so we've got code for the Pico and Pico W. These aren't in the store yet, so you can sign up. I have to finish the tester. It'll be in next week. It's only for CircuitPython right now. I don't believe we have code in Arduino for the camera, although I think some people have written some SDK C++ code for the Pico to interface with these camera modules. And like I said, you know, the camera module is kind of generic. You know, you sort of set it up, you send all these registers, and then it just kind of streams data out in either raw RGB mode, or you can put it into JPEG mode, which is great for snapping a photo. It's compressed, and then you can save it directly to the SD card.
Yes, that's right. That's the product pick of the week. This week, it is the PiCowbell Camera Breakout for Pico and Pico 2. This is a really great little module if you want to do some 5 megapixel, so decent resolution, not crazy high res, but not silly low res either. Photography, sensing of objects, those types of projects. This is a pretty good one to consider. So what we have is, I'm going to jump over to the product page actually for a moment. We have a number of different variants on this. So you can see here, there's a 72-degree lens, which is a, you can think of it similar to like a 50 millimeter and 35 millimeter film term. So it's a neutral perspective similar to human vision. Then we have the 120-degree with autofocus. That's the one I'm holding right here, and that's actually the one we stashed. So there's plenty of these. There's also quite a few of the others, but there were 100 of these to start with at the beginning of the show. This has the little electromagnetic coil package around the lens, which means that it can move that lens in and out to do autofocus. We also have a 160-degree wide-angle lens. I'll show you what that one looks like. It's a fisheye style. No focus on that one. It's a fixed infinite focus. We have the 120-degree low distortion, and we have the 120-degree wide angle also with no autofocus. So we've got a bunch of different variations on these, and they've all got an incredible 50% off price right now for the show. So if you want to get one, throw it in your cart. You can get up to 10 per. I guess you could get all of these and 10 each and go wild with camera stuff. And then for these, you're going to want a Pico 2, probably. That's going to give you some better frame rate on things like live video streaming. And I really like the Pico tripler for connecting to this, and I'll show you why in a second. Let's take a look if you head over here to the Learn Guide and check out some of the features and specifications. So these are using the OV5640 camera module. That's what this little sort of standard module is that's plugged in here. And it's a parallel interface, so it uses a bunch of pins, but this uses the PIOs on the Pico to be able to deal with all of that information coming in. Like I said, it's got the 5 megapixel sensor. We have a micro SD card slot built right on there, and we have some sample code that will just take JPEG photos and save them right onto the card there. So you can push that in there and use an SD card. We have some of those in the store too if you want to get one. Another nice thing, there are a few GPIO pins left over on the Pico because the Pico's got tons. One of which is pin 22, which we have a little shutter button there, a little shutter release button if you want to use that. You can use it for anything, but it's convenient to use as a little take my picture kind of button. What else? There's a reset button built on. There's a STEMMA QT port. So if you wanted to do other interface stuff, maybe add a rotary encoder and do a little camera interface. If you want to have this automatically take pictures when something is in front of a certain distance and use a little ultrasonic sensor or a brake beam or something like that, you could attach that using the STEMMA QT on there. And as Lady Ada said, this is a Circuit Python only. I don't think we have Arduino drivers for this. They may have been created since then, but I'm using it with Circuit Python. And then, as I said, we've got a little example here for doing the TFT mirror demo. So this just streams whatever is in front of the lens to a little TFT screen. And I've got a sample of that that I have. There's a sample of Liz waving. Hey Liz, at her camera. I'll show you that in a moment with a couple of different lenses. And then there's also a nice little sample here of capturing JPEG photos to the SD card, which you can then put in your computer and use. You can also check it out on the pinout page here. Some of the specifics of which pins are free, which pins are used, what pins. You can see here's all these pins used by the camera module. Plus, if you're using the motor there, you've got a little disconnect if you want to disconnect that from 3 volt. And there's also a SD card detect jumper, which you can use to tell when you have a card put into the slot. And let's get to a demo. So I'm gonna jump back to this view here for a second. So you can see here, I've got, this is that 120 autofocus, and that's me there, hello. And we're getting about 4 frames a second streaming there, so you're not gonna do high performance stuff on it, but it's pretty good for a viewfinder. That'll work pretty well as a viewfinder. And then if you've got code that's gonna take pictures when you press your little shutter button, that'll work pretty well. What I've got here is the Pico 2 plugged into the PiCowbell tripler. I've got a free slot here. The reason I didn't use the doubler is that the tripler also has an iSpy connection, so I'm able to have really minimal wiring, which I like. So that little iSpy connection there for display is built into the Pico tripler. And then I've still got a reset button on here, on-off power. I can do battery. This is actually can be powered right off of battery. And then we also have another STEMMA QT slot there and a NeoPixel. So there's a lot you can do with that tripler. For this demo, I've got the screen facing up the same direction as the camera, but you can actually flip that around, put your display, your little viewfinder display on the back there, and make kind of a nice little Instamatic camera style package there. As a comparison, so this you can see, this is this 120-degree lens with the autofocus. Here is the big honkin', put my hand there so you can see it a little better, 160-degree sort of fisheye style wide-angle lens. And if I set these, they're not going to be pointing at exactly the same thing, but if I set these two into view here, and I'll try to cover that light behind me some, you can see how wide-angled that 160 is, and you can see it gets kind of distorted, fisheye style, versus the 120 there, which captures a nice amount of the scene, but isn't terribly distorted either. So those are a couple of options there with those two lenses. I don't have the 72. I don't have that plugged in, but you can take a look at product page for some examples of that, I think. So that's a couple of those little camera modules there. Let's see what else. If you take a look at, I'll show you just some simple bits of the code here. Let me jump over to this view. So that's actually for this one. I believe this is the one I've got plugged in here. Actually, they're both running the same code at this point. So here you can see, to use this in CircuitPython, main thing is this right here, the Adafruit OV5640 library. We're importing that, and then we're setting it up over SPI. We also talk to our display. I've got that set up as well over here on the side. I'm using I2C, and then we have some data pins for all of that parallel data, as well as clock, VSync, href. We're not using the M clock or shutdown. And that I'm setting the size just because we're doing viewfinder stuff at 240 by 240. But that OV5640 size parameter, if you look at the documentation page for that library, it'll show you a list of a bunch of sizes going from, I think, maybe 160 by 160 all the way up to that 5 megapixel size, which is like 2480 by 1920 or something like that. So you can pick the size. You can pick the output. So I'm just using RGB color space to go to the display right here, but you can also pick different color spaces and different file formats for RAW, BMP, compressed JPEG. If you're going to be saving images out to your SD card, you want to make those a little smaller. And then in this example here, where we're just showing on screen, the main loop just uses this command cam.capture bitmap. So grab whatever the camera sensor is seeing. We set that bitmap to be dirty, refresh the display so that we see that, and then repeat. So that's how we're getting about 4 frames a second, I think, with this one right now. So questions in the chat. Can it work with a PiCoW variants? I believe PiCoW does not have enough memory left over because of some of the wireless stuff in memory, but I'm going to guess, and I haven't tried this, and if anyone has, let me know. I'm going to guess the Pico2W can deal with this. If that's the case, then you may be able to set up something like our IoT camera example that we have for the Memento. So the Memento camera uses a really similar module, similar code, but that one's a ESP32 S3, I believe, based chip, so that one has the Wi-Fi built into it. So Pico2W may be possible, but I can't guarantee that. So I wouldn't buy it assuming that, but if you can search around, or if anyone else can answer that, let us know in the chats. That would be helpful. Thank you. All right, let's see what else. I think, let me give you some nice close-ups there so you can see. One thing I will mention, I just added this to our guide, so you can see when you get these, there's going to be a little lens protector there that you can peel off, otherwise you're going to get some blurry photos. There's also a peel-off adhesive stuck to the back of the camera module, so you can remove that little white piece of paper and stick that down firmly, otherwise you're going to have a little wobbly camera there. So you can stick that down and have that secured. I don't actually know why we don't peel those off, but maybe that'll give someone the option if they did want to orient it with like a 3D printed case, something other than flat against the board, you could do that. It does have a short little connection, so you're not going to go far, but you could certainly set this up and take images at an angle on a desktop or something like that if you want to. Otherwise, stick that to the board there. And then in the back, you can see it helpfully tells you all of the pins that are being used. I think 21 of them or something like that, as Lamore said. So we've got a ton of pins used on here, but there are still a few left over for some of those extras that I mentioned. Okay, let's see. Any other questions from the chat? Let me know. Otherwise, we will get out of here. So yeah, go check them out. They are right over here at this URL. Let's go to site page there. Yeah, so head on over there. You'll see we've got these 100 in stock on the 120 with autofocus. And then we've got a few each of some of the others. So the 72 degree, we got 14 of those. We got 6 left of the wide angle. People really like that fisheye. 44 of the low distortion 120 and 34 of the 120. So you can get any of those. And oh, thank you, Dan, over in the chat. Back to the question about wireless. Dan over in our Discord chat, I'll bring that up right now, says in the product description it suggests that it should work with the W. So thank you for pointing that out. And I would maybe look in the forums or elsewhere on Discord to see if anyone has done that with the W or the 2W. I'd go for a 2W. So Pico 2W would be a good bet with that. Okay, thank you. Yeah, Abadu says, I really like that Adafruit puts the pinouts directly on the PCB. That's helpful. It'll disappear once we plug that in. I should show you here. So I've got that running off of battery. Again, the tripler here, the PiCowbell tripler has battery charging built on. Let me get this thing out of the way. Has the battery charging built in and the JST slot for a LiPo. I've got one of those little Feather, I think 420 milliamp hour batteries stuck under there. It fits really nicely. So that's your little compact-ish camera setup with the little shutter button available on there. Okay, let's see. If no other questions, then we'll wrap this up. Yeah, that right there, that's the product pick of the week this week. It is the camera PiCowbell Breakout for Pico and Pico 2. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. See you next time. Bye-bye.